Assalamu alaikum warahmatullahi ta'ala wa barakatuh. This is video number 7 in our video series titled SUMO for Beginners. In today's video, we're going to look at how to generate an abstract network using either the grid, the spiral, or the random network. So if you go to the SUMO website and you typed abstract network, so the SUMO documentation for the abstract network will now show. This is it. So, and they provide a kind of a guideline and procedure on how to generate an abstract network. So, when we say the abstract network, it could be in a kind of a grid that is in this particular form, consisting of so many boxes. Then, and these boxes can either be a square or it can be a rectangle, so it doesn't matter. So, if you want to generate an abstract spiral network consisting of the spiral arm and the cycles, or you want it to be in this particular form, so you can also do it. Then, if you want a random network to make it like more realistic, so you can use this as well. So here, the SUMO website provide the code to be used, like if you want to generate the grid, or if you want to generate the spiral, or if you want to generate the random using the net generate. So the code is as this. So like if you want to do for that of the grid, so you say net generate dot dot, then the grid number, then the grid length. That is if the grid is somehow a square, like if the length and the breadth of the square of the grid is a square, so you can use this. So both of them will now have a length of 400, like for instance. But maybe if it is a kind of a rectangle, so you can use the bottom one. So you can use the net generate, then the grid, then you specify the x number, then specify the y number. Then you can give the grid length in terms of x and y. Then you can name the output file that you want. So I have copied this and I have made some modifications to it on consumption for this particular class. So here we're going to model this. We're going to assume this is our road network, whereby a vehicle can move from here, maybe use this and use this, or they can move from here, here, and there, or they can move from here, come here, and this. So this is a simple a network. So normally if you want to use the net generate, you don't need many steps. So you can do it in 5 or 4 steps. The step 1 is the generation of the network, which is you use this particular command of the net generate. Then you put the dash dash the grid. Then you specify the grid x number, like 3. So what I mean by this is this. So these are the x from here to here is x. So I have x1, I have x2, and I have what? X3. So here the number of the x will now be what? 3. So this is the grid y numbers. So here I can now say this is my y1, this is the second y, and this is what? The third y. So here the y number will now be what? Will now be 3. So I don't want it to be a square, so I want it to be a rectangle. So that means I have to specify the x length and the y length as well. So the x length I chooses it to be 2000. That is it will be 2 kilometer then, because it is in meters. Then the grid y, that is from the x axis is 2000. Then the y has a length of 3000. So you have to specify the number of the lanes that you want to have in the network per directional flow. Like for instance, this is 2, so it means that those that are going in this direction will have a 2 lanes, and those that are coming in the opposite direction will also have a 2 lanes. Then you need to specify the name of the file that you want the output file of the route to be. So in this case, we decided to make it grid.net.sml. So the first thing, you need to open an empty folder meant for this. So after that, you just copy the code. So let me just copy this. Then you now come back to the folder. Then here you click at the this thing. So you now type cmd, just like we did in the previous videos of part 1, 2 up to 3. So now I will paste this. Then I will now uh, press enter. So you see it has said it is a success. So that means it has created the spiral, the grid approach network. So it will combine the edge, it will combine the nodes, and it will combine the type of the road. So what I mean by that is this. So here you see you have how many nodes? You have 1, 2, 3, 4, 5, 6, 7, 8, 9. So you have 9 nodes, because this is each node represent a what? A junction. Then you have how many edges? You have edge, let's say 1 to 2, then 2 to 3, 3 to 4, 4 to 5, 5 to 6. So then you also have the type. Here we specify it to be the default number of lanes to be 2. So under the type, it will now be what? It will now be 2. So if you come back here maybe and open this with the notepad plus plus, or with your normal notepad, so you will now see that it has combined the h, the it will combine the h, then uh, the note and the type. So you can see. So this is so normal, our normal uh, uh, road network file that we use to create. In our second video, I think, or the first one, we use the manual listing to create the type separately, to create the edge separately, and the type together with the node. So we now combine them with net convert. But this time we are using net generate. In the first video, it was net convert we used to combine those to be able to get this particular file. So once you are done with this, so the next thing is to try to assign random trip to this particular network, and you can use that using this particular random trip dot py, that is the Python. The py stands for the Python extension. Then you need to specify the grid that you want to import. So the grid, we name the grid as grid.net.sml. So our network, which is the n, should have the same name as the grid we just generated. So it's going to be grid.net.sml. Then this o dash o means the output file, the name of the output file of the trips that you are generating, the name that you want it to have. So here we decided to use trips.xml. So, and this is the end time of the simulation. So you may decide to simulate it for an hour, maybe 30 minutes, 40 distance. So here we are simulating for 600 seconds. So, and this is the probability. So the rate at which we want vehicles to be in the network after every second. So here the chance of new vehicle being generated in the network is has a probability of 0.1, which is equivalent to 10%. So it means that uh, in every minute there is a 10% chance that a new vehicle will be generated in the network. So as you are increasing the probability, you are also increasing the chance of the vehicles to be on the network. As you are reducing the probability, you are reducing the probability of the distance to be of the car to be, or the vehicles to be on the network. So you need to specify some attribute to the network, like departure lane. Where do you want the vehicles to depart? Because we have the near side and the off side. So those lanes that are very are close to the uh, road medium, and we have the lanes that are very close to the road distance. So here you choose the depart lane. So you better go with the best. So let the SUMO choose the best lane to assign a vehicle in. Then the departing speed, you always go with the maximum. So then the part position you can choose random. Maybe if you have a specific origin and destination of the vehicle, you can as well specify. So when you are done with this, so you just copy this. So go back to the this command center that we have opened initially. So you just paste this, and you now click on press enter. So it will, yeah, so you see it has created uh, the the trip file. So if you open this with the notepad, you see these are the trip. So these are the vehicle ID, the departing time, and it will depart from these edges. Then depart length we say best, depart speed maximum, then departing position. It will going to be random. So maybe in the next video, I'm going to show you how to uh, maybe post this one to have a kind of a vehicle ID like tricycle, motorcycle, buses, and this thing. So give an ID or a class of the vehicle to each of these. So we're going to maybe look at it in the next video. So once you are done with this, so you now go to the next step, which is step 3. So in the step 3, this is where we will combine the network we have generated and the trip we have also generated. So we have to assign this trip randomly on this particular generated network. So now you have the road, you have the vehicles, but they are two different files. So you need to combine them together, and you can do that using the dual router. So in the dual router, you just specify your network file, which is the name of our file is grid.net.sml. Then we need to identify or specify our trip files, which is trip.trip.sml. Then we also need to uh, uh, ask it to ignore any errors that may arise because this is a microscopic simulation. It treats each vehicle differently. So maybe in case if there is an error, so you are now asking the SUMO not to close, but to continue the simulation and ignore whatever error that may arise. So here you just come back to the to this. So you paste the dual router. So you now click on enter. So you see it is success up to the time step we have provided of 600 of 600. So if you come back, you see it has created the root file. Under this particular root file, you see it will match the network together with the vehicles. So you can see this vehicle ID 0, it will depart as 00. It has chosen departing length as the best, then the passing position as this, then the route. So you see here it will follow this particular route. So it has now matched the network and the vehicle. So now you are good to go. Initially in our first video, you remember if we want to come up with the SUMO config file, this is the normal way we do it. So we just write the code and save it in XML, sorry, in SUMO config. Alternatively, you can use a code to call the SUMO and run the simulation without undergoing this process. In our previous in our last videos, so these are the ones, this is the approach we adopted. So but now you can as well use this command to just call the sumo and you continue with the simulation. So let me just say copy, then here I will just paste it, then I will now run. So you see it has started the sumo. So you have to make sure that uh, the this particular shape the pigo depict what you intend to simulate. So if you look at this, this is what we intend to do. So it has 4 boxes, 1, 2, 3, 4. So you see the same thing here. It has 4 boxes, 1, 2, 3, and 4. So maybe you can now maybe increase the delay. Maybe let's change this one to let's say to make it a raster image. So you click on the vehicles, then change the triangle to a raster image. So you say OK. So you can begin the simulation. So if you zoom in, so you can now see the vehicles. So you see each of this one has a number of two lanes in each directional flow. So now maybe if you want to change this, you can as well do that. Maybe I want this to be three lanes, and maybe I want the network to have more rods, so I can decide to do that. And later I will show you, like for instance this junction, how to change it to become a kind of a signalized intersection, and how to configure the traffic signal. So maybe you can also conduct a research to see effect of the signal timing, maybe on the CO2 or the emission of the vehicles. So how much the distance, or you can compare the emission at intersection with the normal route network. So you can do a lot of things with that actually. So we're going to look at this later. So now let me just maybe go and change some things and see where it will this thing. So now let me change this to be, let me change the number of the y to 4, and let's say the number of the x, should I leave it 3, or let me just also change it to be 4. So that means now I'm adding another distance to this. So I will not going to have this particular shape, because now I have added the number of the y and the number of the x. So now instead of 3y, 1, 2, 3. So now I will now have another one. So now instead of 1, 2, 3x, so I will now have another one at the bottom. So here, if I want to change the number of the lanes, so let me just make it 3. So let me just copy this. So I will copy this. So come back to this. I think it should be able to update itself. So I will just paste this, and I will now say enter. So you see it is now a success. So since now I have already changed the network, so I have to run the dual router again to recombine the new network I have created with this particular new. So you just copy this, and you now paste it. So you now press on enter. So I think so it is success. So by now it should be able to change. So, but what I will do here is that I will go to the refresh. So you see it has already changed. So it has now added the grid that I have listed. So you can as well run the simulation. So this is how to use the SUMO this thing, the SUMO uh, abstract network generation using the net generate and the dual router. You see in our earlier video, we created the root, we created the H file in XML, we created the type file in XML, then the not file, then we combine them using the net convert, then we later create the root file manually, then we use this particular format to have the SUMO config file. So, but in today's video, you see how we utilize the abstract. So now I think you can just go ahead and try that of the spiral. So this is you can copy this. This is it for the spiral. So all what you just need to do is to specify the spiral arms number, and I'll say these are the arms. These are the arms. Then you now specify the spiral cycle number. So you depart this thing and the name of the network that you want uh, the output to name it. So you just specify it. So maybe you can just copy that, and let's say maybe, so let's paste it here. So that means, but you need to where is it? So this is for the spiral. So that means you need to like somehow uh, edit this, like the name of the output file, so you can replace it with this. So the output file, so make it to look in this just edit it and make it to look in this particular format. So then try it. So assalamu alaikum warahmatullahi ta'ala wabarakatuh. We'll see you in the next video.